All right, so sorry, I made a little glitch there on that video. My last one, the marathon's almost over. We're going to look at De Moivre's theorem, the last piece. Without any further ado, I want to get out of here. So let's finish. So I gave you one unit circle base and one not. So if I go over 2 and up to I, I've got a modulus of 2 roots of 2. And of course, an angle of pi over 4. Now that's the root question. Now, in De Moivre's theorem, I'm wanting to take that to the 5th power. So I'm going to take 2 roots of 2 to the 5th, and I'm going to multiply the angle, because that's what De Moivre's theorem says to do, is just take the radius to the angle, and then let's take the angle and multiply it by that exponent. Now, as it turns out, you might be like, oh, that's going to be gross, but the cosine of 5 pi over 4 and the sine of 5 pi over 4 both have a bunch of root 2 over 2's in them. Now, I'm going to be a little teeny bit lazy because I think I know what it's going to be, but I just want to make sure. So I'm going to take my calculator, and I'm going to ask it to take 2 square roots of 2, and let's raise that to the 5th power, okay? Got a weird number here, right? That's what this is. And I'm going to multiply that by negative root 2 over 2. Oh, it's just negative 128. That's amazing. So if that's negative 128, then this is also negative 128, and I'm actually done. Now I could check that answer very, very quickly on my calculator, because it almost seems silly to do all that other work, kind of, because it is. But we at least now know how to do that, and you'll notice I got exactly the same answer when I just typed the question in. So just for fun, I'm going to do that over here. 1 minus 2i, and it's raised to the 4th power. I should know by the time I'm done, I missed that, this answer should be a negative 7 plus 24i. And I'm hoping that that is the answer that I get, but let's see what happens. So again, start by getting into the proper form, the trig form. The modulus is going to be root 5. Now, this is not going to be a pretty one. So I'm going to, again, use that angle feature to find out what angle is it if you go over 1 and down 2. Now, remember, that's the angle we're here. And De Moivre's theorem says if we want to raise something to the 4th power, we're going to take the radius and raise it to the 4th, and we're going to multiply the angle by 4. Now, what I personally like to do is I like to store this value as A or B or something so that I have it for future reference. But now all I have to do is, using that machine, let's take root 5 raised to the 4th, and let's multiply that by the cosine of that angle I stored as A. And my calculator says negative 7. And then if I did the same thing, but use the sine, because remember it's I sine, notice that I got the number 24. And I'm done. That's awesome. And the last question for the marathon session, for me at least, because I'm doing this all in one session to be done, is to find all of the 4th roots of negative 16 and all the cube roots of 125i. So what I look at is, if I think of z as the number negative 16, that's 16 units away from the x-axis, from the origin, and that's sitting at the angle pi. So what we're going to do to find that is we're going to take the 4th root of it, and the 4th root of 16 is actually going to be 2. And then De Moivre's theorem says you take this to the 1/4 power and you multiply that. And so you get pi over 4. Well, as it turns out, that's actually a pretty nice number. That's the first answer. The second answer, also 2. But because there are 4 answers, I'm going to evenly distribute those 4 answers across the full circle. So there's 4 answers distributed across. So my second answer is going to be 3 pi over 4. My third answer is going to be 5 pi over 4. And my last answer is going to be 7 pi over 4. So we're just evenly distributing every 2 pi over 4. And as it turns out, this is actually pretty nice stuff, because these are all root 2 over 2's as we go down the line. So my first answer would just be root 2 plus root 2i. This is almost the same, but because it's in the second quadrant, I have slightly different pluses and minuses. This one, they're both negative, because this is in the third quadrant. And you might notice that we're getting all of these different renditions of root 2's plus and minus root 2's of i's. And so this is the trigonometric form. Here is my rectangular form, also known as standard form. And then my last problem, there's just kind of a weird one. It's like, how do you find the roots of 125i? So again, 125i is up here. So if I thought of 125 units at the angle pi over 2, if I want to find the cube root, I take the cube root of the front value, 5, and then I multiply pi over 2 by that fraction 1/3. That gives me pi over 6. That's my first trig form. Now there's going to be one of those new answers every 2 pi over 3 or 4 pi over 6. So that means my next answer is going to be at 5 pi over 6, because again, pi over 6 plus that. And my last answer is going to be an additional 4 pi over 6 or 9 pi over 6 away. 9 pi over 6 reduces. So there's my trig form. And then if I wanted to write it in the other form, the cosine of pi over 6, the sine of pi over 6, done. Over here, the cosine of 5 pi over 6, the sine of 5 pi over 6, done. And the cosine of 3 pi over 2 and the sine of 3 pi over 2, or in other words, just minus 5i. There's my 3 in trig form and my 1, 2, 3 in standard form, also known as rectangular form. That's going to do it. That's the end of the review. Hopefully that was helpful to you. I will see you back in class.